y-intercept, and slope of linear equations.
I don't get it. What do I need to do? No entiende.
We are going to look at, this is a linear equation, y equals. Okay, so called slope, intercept, form.
So, esto es un tipo de ecuación de línea, slope intercept form. ¿Es el nombre de esta fórmula? Is the name of that formula?
Yes.
Okay.
Okay, so the reason it is called slope intercept is because it literally tells us what is in the problem. It tells us that we have both a slope, which is M, and a intercept, which is B.
So, el nombre de la problema describe exactamente cuál información está en la problema. Okay.
All right, are you with me so far?
Yes.
Okay. All right, so the reason we have this equation, and we have, let me see if I can do a different color here, and we have these two things here, X and Y, is because X and Y represent a point. We talked a little bit about this the other day, Miss Sickmeyer.
Oh, so la X y Y en la ecuación están los mismos X y Y de los puntos de gráficas.
So when we make our tables,
Yeah.
X and Y, and we make our graphs, those points from our table, this point that goes over here to the graph, comes from this X and Y.
Okay.
So that's why when we plug in 0 for X, that's why we get our y-intercept, which we talked about a little bit the other day as well.
So the y-intercept is when X equals 0.
Perfect.
So what's next?
So when we're trying to graph something or make a table, which table and graph are essentially the same thing. When you make a table, you've made a graph because you have made the points for the table. When you have a graph, you've made a table because you just take those points and you can make a table from it. So they are
a table, una mesa, y una gráfica están el mismo información. They're not the same thing. They have the same information.
Right, exactly.
Yeah. Dos maneras de compartir la misma información. A table would be this right here, the T for table. Mm-hmm. And the numbers like 2 and 4 would be the same information you would get in a graph that would have the y-axis and the x-axis. That's my y. And then all these little guys on there. And so 2, 4. So it's the same information here and here on the graph and on the table. Okay.
That was very well explained. Beautiful. So that's kind of our foundation. So when we go to do the slope and the y-intercept, those come from our table. We can get them from our table. We can get them from our graph, and we can get them from our equation. Uh-oh.
Now I get that we can get, yo entendí que nos podemos obtener el y-intercept from the table, because anytime that x is 0, the opposite number is the y-intercept. So anytime x is 0, then whatever number is across from it is the y-intercept. Which is b.
Correct, yes. Mm-hmm.
And then we can also get that in the graph, from whatever point crosses the y-axis. La punto de cruzar el y-axis es el y-intercept. Porque x es 0, porque no mueve ninguna manera horizontal. Solo mueve arriba o abajo. Okay? But where does slope come from?
Okay, so slope is, when we did the table the other day, It was the change in y. Remember, we were counting was y going up or down in the table, and over the change in x was x going up or down in the table. So slope is essentially how does your graph change as it goes up or change as it goes down?
So los cambios en los gráficas. So then if I put a graph here
Mhm.
and a table, which looks a lot like a graph,
Yep.
there. And so the graph would be like this,
Mhm.
and the table X, Y. Mhm. Okay, so what do you mean the change? When you say the change, cuando dice el cambio, like, ¿cuál es el cambio?
Okay, so Ms. Sigmar, go to X in the
Yeah.
table for me and write these numbers for me. Negative
Okay.
2.
For X?
Yeah. Negative 2.
Yeah.
Negative 1.
Okay.
0. And 1. All right, let's do negative 1 for the first Y.
Negative.
No, actually, negative 3. I'm sorry. Do negative 3.
Negative 3.
Yeah, negative 3. All right, negative 1.
Negative 1.
1.
1.
And 3. Okay, now it'll fit.
3. Okay, so these numbers I could put up here on the graph.
So let's do that. Let's go ahead and put those numbers on the graph.
So negative 2x would be going back 2, and negative 3y would be going down 3. 1, 2, 3. And so I'm going to put a star there.
Do we want to remind them about starting at this middle point every time this origin?
Todas veces empezar al centro de la gráfica. We always start there. Every dang time. Okay. Then the next one is negative 1, negative 1. So if I go back and I go negative 1 and then down 1 for negative 1, that's going to be right there.
Yep.
Boop. 0, 1. Well, 0 means we stay right there. 0 means we stay right in the middle, but we go up 1. So we don't move horizontally. We just go up 1.
Okay, Ms. Sigmar, I'm going to ask a question, and we're just going to pause for 5 seconds and let them kind of answer the question to themselves.
Yeah.
What is that point called that we just plotted?
¿Cuál es el punto aquí que nos dibujar a la gráfica? ¿Cuál es este punto?
Okay, hopefully you said the y-intercept.
Y-intercept.
Because
it intercepts the y-axis. So this point right here, este punto es el y-intercept.
Y-intercept.
Porque tocar el axis de Y. Okay, so that's the y-intercept.
Y-intercept.
So what do I write for y-intercept
Y-intercept.
again?
Okay, there's it's a point, so we always write it in the form 0 and then some y.
Y-intercept
Y-intercept.
equals 0. And in this case, what is y?
1.
1. Okay, but sometimes it's just 1.
Sometimes you may see it written as y equals 1. Yes.
So algo veces y-intercept
Y-intercept.
es un grupo de 2 puntos y otro veces es solo el número de Y. But either way, 0, 1 or 1 are the y-intercepts
Y-intercept.
in this table and in this beautiful graph. Okay.
Okay, so to answer your question about slope,
Slope.
look, there's 2 things we need to look at. First of all, does our graph look like it's going up, or does our graph look like it's going down?
So primero, para identificar el slope,
Slope.
decide la dirección de la línea de la gráfica. ¿La línea ir arriba o la línea ir abajo? And I'd say it's going up, ir arriba.
You would be right. It is going up. It is positive.
Because we read from left to right.
Correct. Yep. All right. So how do we get the slope?
Slope.
All right. Now we can get it from the table or we can get it from the graph. Essentially, we are doing it the same way. So it's a lot easier to get from the table. So I think kind of what we established the other day was they should always make a table. No matter
Okay,
what.
so cuando necesitas identificar el slope,
Slope.
es más fácil identificarlo con una mesa de una gráfica. Entonces, que su problema solo da a ustedes una gráfica, necesitas hacer una mesa como eso para identificar el slope.
Slope.
Porque esa es la manera más fácil para identificarlo.
So when we do that, if we look at the x's first, each
And-
value is going up by 1.
Ok, entonces, que nos mire a el columno de X primero. Cada número está más alto de 1
And each y is going
para
up by
cada número.
2.
Para Y, sumar 2 para cada uno. Ok.
Right, so slope
Slope.
is m. The letter m represents slope.
Slope.
So the slope,
Slope.
there's only one way to write slope.
Slope.
There were 2 ways to write y-intercept.
Y-intercept.
There's only one way to write slope.
Slope.
And it
Okay.
is y over x. So that's kind of ugly, y over x.
Y over X. So I have to write like -3, -1, 1, 3 over
Nope.
-2, -1, 0, 1.
That's a good question. No, so I put this little thing in front, this little triangle, that means change. So,
So el triángulo
y-
representa cambio.
so what was the y changing by? What was the number it was going up each time?
So el cambio en los números de Y sobre el cambio en los números de X. So we would write M, oops, I gotta type something. We would write M equals 2 because that's the change in Y
Right?
over 1 because that's
Correct.
the change in X.
Yep. And since it should be a positive number because at the beginning we said our graph was going up. So do we have a positive number? Yes. So our number matches our graph.
Okay, so if the graph goes up, the number is positive.
Very good.
La línea en la gráfica ir arriba, los números para slope
Slope.
están positivos. Okay, well that's good. But what do I do with it? So now I've identified them. Is that it?
Yeah. So that's all we're doing right now is simply identifying those two things.
Okay, so la meta para hoy es solo identificar los dos cosas.
Is in this slide, I've made some examples of equations, graphs, and tables. And we're going to, from each one of these, we're going to try to find both the y-intercept
Y-intercept.
and the slope.
Slope.
Okay, y-intercept
Y-intercept.
and slope.
Slope.
Okay. We said that B is the y-intercept
Y-intercept.
and y equals mx plus b. So whatever is in like this space right here, whatever is right here should be the y-intercept, right?
So what I think we should do is just give them a minute here to go through, to write these problems down on their paper, and to write out the y-intercept for us. I will do the first example, and then they will try the next 3. All right, so first example. I think it's good, possibly, go under this and write the letters. Because if they understand the letters, then they can just look and find the letter and look above it.
Okay, una estrategia que eso es difícil por ustedes es escribe la ecuación y equals mx plus b debajo las ecuaciones Mr. Harrell escribe para nosotros y solo identificar cuál está sobre b y eso es y-intercept.
Y-intercept.
So is it 6?
It is -6.
Oh, so the sign in front goes with the number. El símbolo a frente de la número está con el número.
Correct.
So it's not, no es solo 6, es negativo, 6 negativo.
So that's like an imaginary plus sign there. So it's like plus -6.
So algo veces es más y algo veces es menos. It doesn't have to be plus.
Right. So the y-intercept would be 2 ways they can write it. 0 negative 6 or y equals negative 6.
And for this exercise, write both.
Write both, yes.
Para este ejercicio, escribe las dos maneras. Puede expresar su respuesta a este problema. ¿Cuál número es el y-intercept?
Y-intercept.
So, continúas a hacer los siguientes 3. Toca pausa a su pantalla. Y cuando terminaron, toca play y nos continuamos.
Okay, so this one is 11-0. Oh, look at me. 0-11. Y equals 11. 0-2. Y equals 2. And 0, negative 7. Y equals negative 7. All right, there you go.
Those are your answers. If you didn't get them, you should let us know later.
Yes.
And we're not really here.
Maybe attend a meeting. I don't know.
Oh, show up to one of the meetings we offer, since I offer 2 a day and you offer 2 a week.
Yeah.
So they literally have 10, 11, 12 opportunities. 12 opportunities a week to talk to us.
That's 7 more than most kids get in classes.
It is indeed. It is. It's a lot of opportunities. We miss you. Next slide.
Now we have graphs.
Okay.
So to find the y-intercept
Y-intercept.
on a graph, it is quite simple. Remember, it's where it intercepts the y-axis.
Para identificar el y-intercept
Y-intercept.
de un gráfica es donde un punto de la línea en un gráfica cruzar el y-axis. I just write the coordinates for that.
So this one would be 0. So remember, 0 is always first, and then that number right there is 3.
0, 3.
Or y equals 3.
Both are correct answers. Okay.
Yeah. So let's give them a second to try the second one. 0, 5, y equals, that's a bad y, 5. There you go.
Okay, so that's how we find it on a graph and in an equation. Are we done?
We got to do table.
Okay.
Table, same thing. You're just looking for when x is 0.
So on the first table on the left, first one says x is 0 right here.
Uh-huh.
So this right here must be the y-intercept.
Y-intercept.
So I would write parentheses 0, comma 3, or y equals 3. Your turn. Try this one at home. So for the next one that you guys just tried, the x that has 0 is across from a 0 in y. So it would be parentheses 0, comma 0, or y equals 0. Is that right?
That is correct.
They can both be 0?
That's the origin.
Right. Okay, so we identify the y-intercept.
Y-intercept.
Do we also need to identify the slope?
Slope.
Yes, we will do that next.
Cool.
So back to equations again.
Y-intercept.
Y equals mx plus b. So now we're looking for m.
Okay, so en los problemas pasados nos buscamos para b, y-intercept, y ahorita nos necesitamos identificar m para slope.
Slope.
So in this problem, m is 3.
Oh, just the number that touches
Yep.
x. Solo
That's
el
it.
número que tocar el x. You don't write it as coordinates ever? It's just m equals 3?
No, it's not. Yeah, it's not coordinates because it's a ratio. It's a fraction. So,
But
it's-
that's not a fraction. That's a 3.
okay. So, yeah. Yes and no. So, I know this is a question in one of the quizzes, but slope is really what is called rise over run. It's like how much you go up and down, which is y, over how much you go left and right, which is x. So there's always
la cantidad de mueve arriba y abajo para y, rise, y la cantidad de mueve horizontal, run, x. That's slope.
So let me ask you this, Mr. Now, what do you think the run is in this problem? Can't see it, but it's there.
Y?
No, so y is 3. That's why we have 3. The right, so it went up 3. What do you think it went over?
I have no idea.
1. 3 divided by 1 is 3.
Oh. So, cuando m es solo un número, representa una fracción que tiene uno abajo. So, really, even if it doesn't say a fraction, it is a fraction.
Right.
Okay.
They're all fractions, except, I'm sorry. They are all fractions. Sometimes that fraction is just reduced.
So, todos sus resultados para m estas fracciones, pero algo veces la fracción está, como nos decimos, reduced, cuando nos cambiar a la forma más simplificada, y la forma más simplificada de 3 sobre 1 es 3. Okay.
You need to look at the number next to x.
Mira el número al lado de x. Okay. We'll pause here while the kids at home try.
So this one is m equals -2 over 3. This one is m equals 15, or 15 if they want to get in the practice of it, because this is not wrong. If they wrote this, it's 100% correct. So here's a graph. So a couple slides ago, we said no matter what, when we had a graph, we always wanted to make a table.
Right. No importa que tú tienes tu gráfica y necesitas identificar el slope, necesitas hacer una mesa también.
So, Ms. Sigler, I'm going to circle.
Graph, we make a table.
I'm going to circle those 4 points. Do you mind writing those coordinates in the table for us?
I can do that. I'm a mathematical genius.
Yes, you are.
Thank you. So the first one we start in the center right here, and it's going to go backwards 1, 2, 3, and then down 1, 2, 3. So it's -3, -3.
Correct. Yeah.
And then the other one goes back 1 and up 1. So the back one is -1, up 1 is just 1. And then this one just goes up 3. It doesn't go side to side. So 0 and 3. That must be the y-intercept because 0 is right there. And this one goes over 1 and up 1, 2, 3, 4, 5. 1, 5. Did I get them right, Teach?
You did. You did. Yeah. Why is something wrong here? -2, -1. You know what? I want to change something real quick.
Bad example?
No. Fine example, but I want to point something out. So let's keep the -3, -3, but let's erase everything below that real quick. And I want to show you why. So right here, there's like this gap. There's an actual point there. So let's write that point so we have a consistent slope.
Oh.
Yeah. They're messing with us on this example.
Okay.
I'm going to erase this circle. All right, we're going to do these 4 points. So -3, -3, first one, good.
And then the next one was -2, -1.
Right.
Because we went back 2 and we went down 1, and down is negative. And the next one was back 1, up 1. Back 1 is -1. up 1 is positive 1. I guess you don't really need the plus sign. I guess it's just 1.
Yep.
And then the next one is 0. And up
0,
3.
yep. Yep.
Okay.
Okay. All right, so now we can find the slope.
Slope.
So we're going to look at each one of these and see how much they went up by or down by. Okay, so
Well-
-3 to -2. Did you go up or down? Did you increase or decrease?
Well, the slope
Slope.
goes up,
Yep.
so it has to go up.
Okay. So it went up 1.
Yeah. And then up 1, up 1, up 1.
Very good. Okay. Now what about the
And
y?
next, -3 to -1, up 2.
Went up 2. Good.
And then up 2, up.
Mm-hmm. All right. So that's how we know we have a linear equation too, because the number is the same every time.
Oh, linear equation, the equation of a line in a graph.
Yeah.
Okay, that just,
It's clicking.
yep.
It's got to be a consistent rate of change for it to be linear. That's what makes it a line.
Okay, so if it's a curvy line, it's not a line anymore.
Right. And it's not going to have, these numbers are going to be different. It might go up by 2 and then it might go up by 5. And
So
then
this is the equation for a straight line. Es un línea recto. Okay.
Okay. So then our slope, remember, is m equals what y changed by over what x changed by.
Change in
So-
y over change in x. So that y changed by 2.
Mm-hmm.
And then the x changed by 1.
So there's that 2 over
1.
1. But if we wanted to reduce it, it would reduce to 2.
Right. So m equals 2.
So that's why I'm saying they have a calculator. They probably don't need a calculator for that. But if they just wanted to get in the habit of trying to divide every time, and here's why they need to divide, because if they divide and they get a whole number, they need to write that. If they divide and get a fraction or get a decimal, then they don't.
But they would only get a whole number. Oh,
Yeah.
okay.
So even if it was like 10 over 5, that would still reduce to 2.
So es importante que reducen sus fracciones. Y que no sabes cómo hacerlo, usa un calculador y es el número sobre, divide el número abajo y que su resultado es un número normal, un whole number, un número completo. Es su respuesta. Es posible, tiene, what'd you say, 10 over 5?
Yeah, 10 over 5.
10 over 5, 10 divide a 5 es 2 también. So necesita entrar su fracción en la calculadora a la fin y que no es un número completa, que es un número con decimals. Necesita escribir su fracción. No puedes hacer más aplicada.
So we have another example that we can let
Good.
them try. Let them try, and then we can go over it.
Okay.
So let's circle the points for them to use. That one, and that one.
Try this one at home. What is the slope?
Slope.
Okay, now tell us.
All right, Ms. Sickmeyer, is this graph going up or down?
Down, because
Down.
it was Mario walking from the left to the right. He would have had to walk down that line.
So should our slope
Slope.
be a positive number or a negative number?
Negative?
It should be a negative number.
Okay.
So x from 3 to 2, that went down 1. So we're going to write
-1.
-1, -1, -1. Okay. And then this is going up by 2.
Oh, wait, but why still go up?
So y still went up, but x went down. So we have a positive and a negative, which gives us our negative.
Okay.
So m is, I'm going to write this every time, changing y, we're changing x. So what did y change by? Positive 2. But x changed by negative 1. So if you reduce that, that's where you get a negative slope and why your graph goes down.
If they're writing the coordinates from a line, they should always start at the bottom.
You know what? If they had done it the other way and started at the top, then their x would have been going up and your y would have been going down, but it would have given the same thing.
So it doesn't matter. No importa que empiezas con la punto aquí o la punto aquí. Uno de los números es negativo y cuando un número en un problema es negativo, su respuesta es negativo.
Should we show them that?
Yeah.
Okay. That was actually a really good question. I didn't even think about that. So yeah. So let's say instead we went and did this point first. So we did 5, 0 first, and then that's 0, 5. Sorry, 0, 5, and then 1, 3, and then 2, 1, and 3, negative 1. So here, these are going up by 1, but these are going down by 2. So there we are. We still get that negative 2 over 1, which gives us negative 2.
Okay. So no importa cuál número es negativo. Un número es negativo, su respuesta es negativo. What if they were both negative? Does that ever happen?
Yes,
And then is the answer positive?
it is.
So en la ejemplo.
But look, the only time they would do that would be like if we go back to the last example. Let me click back to the last example. That would be if they went and did, you know how we worked up on this one?
Yeah.
It would have been the same thing. So we worked up, but if they would have worked down, these would have been going down, these would have been going down, negative over a negative is positive. So I would recommend that they just always work their way left to right. So
Okay, so no necesita preocuparse de dos negativos, que todos veces empezar a la punto más izquierda y terminar a la punto más derecha. And then you don't have to worry about double negatives. It'll always be both positive or one negative, one positive.
I think the last thing we have to do is look at a table, which we should already know how to do because we just did it.
So you just look at the change.
Yep, just look at the change. So we almost could have done this one before we did the graph. Should have done them the other way. But you know what? We shouldn't even teach this, so we should just have them practice it.
Yep, they can do that one by themselves. The change in Y over the change in X.
Okay, now this is going to be one of those ones where it's going to reduce, but it's going to be a different number than 1 on the bottom.
So make sure you put the answer in your calculator.
So plus 2, plus 2, plus 2, plus 2, plus 8, plus 8, plus 8, plus 8. So the slope, change in y over change in x, positive 8 over positive 2. Type that in your calculator. 8 divided by 2 is 4. So, Ms. Sitgarni, see how the numbers went up by 2 instead of 1?
Yeah.
So that's why the slope is different than 8, because there's like a hidden number in there. Like 1 would be right in between there, right?
Yeah.
Whereas 7 would be right in between there. So 3 to 7 to 11, those are going up by 4.
Oh. I kind of see it.
Yeah. So like the table didn't go up by 1. So that's why. So normally all the examples we've been doing, the x's have been going up or down by 1. Now we have one where it's going up by a number bigger than 1.
I'm the type of thinker that just, I understand what we've done and I understand why we put the fraction in our calculator, and I don't need to know why we did it. I just need to know that we did it. And
Okay.
10. But I'm sure there's someone who wanted to know why.
Brian did.
Stands hidden numbers.
Oh, is that math?
It is math.
I don't think so.
Oh, you want to do something? Okay. So y'all going to do this one as well.
Yeah. I'm done. You done with cleaning?
Hey, how much is that number going up by? From 13 to 16. How much do you have to add to 13 to get 16? Do it. Start at 13.
13,
Add to get to 16.
14, 15, 16.
So how much did it go up by?
3.
3. Good. My son said this one up by 3.
Son's a genius.
You're right.
He has to be in the video now. We have to see his face since he did the work.
Can you smile? Can you see him?
Go down a little bit. Move your screen down. There it is. Hi.
Hi.
How are you?
Good.
What's your name?
Lawson.
Do you like having a math teacher as a dad?
Yes.
Nice.
Lawson was doing big numbers today for math. He was adding and subtracting numbers in the 20s.
Like a boss. Get it, Lawson.
Thanks.
He's shy a little bit. All right. So then these are going down to
Right, because they're negative.
negative. Yep. So our change in y over our change in x is positive 3 over negative 2, which you cannot reduce. So that's the answer. Because if they put that in their calculator, they get a decimal. And so they're like, nope, don't need to do that.
So this will help them. They need to study the vocabulary words in assignment 1.5.
Correct.
And this will help them do assignment number 3.
It should help them do assignments 1, 2, 1, 1 and 2, and 3, I think.
1, 2, and 3. All right, so by watching this video over and over again, because you just miss us that much, you should be able to do assignments 1, 1.5, 2, and 3. Not all at once. You can break them apart a day.
Yeah. But I mean, they need to be doing something. They need to be catching up.
All right, Mr. Harold, this went really well. I feel like I understand math now. Wow.
Good.